Good morning. If you have any questions, just let me know. No one has any question?
Sir, syllabus for minor, like up till which?
आज तक रहेगा today till today's class. Okay. Next two lecture, a bit I will discuss about this catalysis again, but mostly we will discuss tutorials. Okay.
Okay, sir.
I will again upload few more tutorials today, so please go through it. And I think on Sunday your exam is scheduled. Am I right?
Yes, sir.
Okay. No questions? Okay, so then let me go ahead. Okay. So I was discussing in last lecture about what is the different mechanism through which catalysis happens. Okay. So we discussed few of them. Right. Uh, so let's go ahead and, for example, first thing we discussed is differential binding. So this can be one of the mechanism. Then we discussed about covalent catalysis, a catalysis by approximation. In this, we discussed about effective concentration. So this is one of the way which catalysis can happen. And then we discussed about covalent catalysis, in which one intermediate is formed which reacts with the other reactant quite fast. And this was the free energy diagram for your covalent catalysis. Then we discussed about electrostatic catalysis, in which the transition state formed is stabilized by some of the group nearby. And we discussed about few proteins, how they catalyze a particular reaction. For example, these proteins are proteases, and through serine or cysteine, they stabilize the transition state, and hence, it catalyzes the reaction. And this was one of the example in which this transition state form is stabilized by what is known as oxyanion hole. Okay, so these things we have already discussed. What I didn't discuss last time is sometimes metals also stabilize um, uh, through metal. Metal can also act as a catalyst. Electrostatic charge developed at transition state uh, is stabilized by metal ion. coordination of a ligand by a metal can also lead to polarization of the ligand. So these are the ways in which metal can catalyze the reaction, metal ion basically. So for example, pK of metal bound water is 7.2. So that helps uh, water to deprotonate. Okay. So OH minus ion is formed quite easily, and that OH minus ion can act as a better nucleophile in comparison to water. For example, in carbonic anhydrase, zinc acts as a metal catalyst. When it binds to water, then OH minus is formed, which can act as a better nucleophile. So till now we discussed about different ways a catalyst can increase the rate of reaction. Now we are going to discuss one by one three different kind of catalysis. First we will discuss homogeneous catalyst, and then we will discuss heterogeneous catalyst. In homogeneous catalysis, we will discuss acid-base catalysis and enzyme catalysis. And then in heterogeneous, we will discuss about if there is a solid state catalyst, how that can, increase the rate of reaction. Okay, so firstly, acid-base catalysis. This is quite common in organic reactions, in which acid and base can act as a catalyst, and that happens through protonation or deprotonation. So let us see this example. Okay, so this is hydrolysis of this ester that happens in presence of H plus. So what H plus does, that it forms bond here. You can see this at oxygen a lone pair, and it transfers this lone pair to hydrogen. So this plus charge is formed, and that basically shifts this electron pairs toward this side, and water can now act as a better nucleophile. So water is acting here, and then the transition state which is formed is stabilized by this H plus ion. So what happens, that this bond pair goes to this positively charged, and then you have this kind of a species form, and then this can by this lone pair will attack at this hydrogen, and this bond pair will go to this OH plus, and finally you have a hydrolysis product which is formed here, and H plus comes out, and that's why H plus acts as a catalyst. So ester hydrolysis is generally done either in presence of H plus or H minus ion. So here H plus ion acts as a catalyst. Okay. Again, so there are two type of catalysis, acid catalysis. One is general acid catalysis, and another is a specific acid catalysis. In the next slide, I will discuss that. But in general acid catalysis, it is not H plus or OH minus which will act as a catalyst, but acid as a whole can act as catalysis. Okay, so so you see this here. So this is catalyzed through there is a base catalysis. You say acid or base, anything can catalyze this. So here one example is given base. Base is extracting this H plus ion, and so this lone pair will attack this bond pair, which is now free, will attack this carbonyl carbon, carbonyl carbon, and this is formed, and then there is hydrolysis of to give this product. So this base as such, I am not writing OH minus ion, base as such can act as a catalyst, and this is known as general acid catalysis. Okay, so any question here? Any question which you like to ask? No? Okay. So let us go to next lecture. Okay. Okay. So catalysis, as I discussed in the last few slides, that catalysis can be of two types: homogeneous catalysis and heterogeneous catalysis. Okay. What I mean by homogeneous catalysis, that phases of reactants and catalyst are same. Okay. Phases of reactants and catalysts are same. In this, there are two different topics which we'll discuss. One is acid-base catalysis, and then there is enzyme catalysis. In heterogeneous catalysis, the phase reactant and catalyst are phase of reactants and catalysts are different. For example, reactants can be in liquid phase, but your catalyst can be in solid phase. So we are going to discuss all three catalysis one by one. Okay, so acid-base catalysis. Uh, in acid-base catalysis, there are four species which can affect rate of reaction. One is H plus, OH minus, base as such, and then acid as such. Base, only base is affecting and acid is affecting, not the OH minus or H plus ion in that. All four species can also catalyze at the same time. So there are different for different reaction. There are different kind of acid-base catalysis. So for example, log K versus pH, you can see that the rate is increasing as H plus ion is decreased. Okay, it means you are going to uh, sorry, pH is increasing means it is a kind of base catalyzed reaction. So acid catalyzed, you see there can be three different things. So this side, if pH is increasing means H plus is decreasing. So if you go to this side, H plus is increasing, and then you see that H plus is increasing, then K is also increasing, and that means this is acid catalyzed reaction. So by looking at the rate of reaction or rate constant with respect to H plus ion concentration or pH, you can know whether that reaction is acid catalyzed or base catalyzed. So in this, only on increase in H plus ion, the rate of reaction increases, and hence this is acid catalyzed reaction. Okay. Uh, but at the higher pH, you see there at higher pH there is increase in um, no increase in increase in rate of reaction. It is almost constant. It means that this side your OH minus ion increases, and so it is not OH minus ion catalyzed reaction. So this is only H plus catalyzed reaction. A base catalyzed, you can see that this is just opposite. So pH is increasing, it means OH minus ion, H plus ion is decreasing and OH minus ion is increasing. And you can see that there is an increase in rate of reaction with pH. Okay, that means this is base catalyzed reaction. There are cases in which you can see this kind of thing, log K versus pH. And if you are increasing H plus, then you will see rate of reaction increasing. And also when you increase OH minus ion, the rate of reaction is increasing. In between, there is no change in rate of reaction. It means it is both acid catalyzed and base catalyzed. OH minus, it is better to say because this is pH. So H plus catalyzed reaction, and this is OH minus ion. So it is both H plus and OH minus catalyzed reaction. You can have cases in which you will have this V-shaped profile when you plot log K versus pH. So almost at every uh, you know like if you take this point, this pH, below this also there is below this there is acid catalyzed, and above this there is base catalyzed reaction. The same reaction can be catalyzed by both H plus and OH minus ion concentration. Okay. In acid catalyzed, there can be two different kind of reaction: general acid catalyzed reaction and a specific acid catalyzed reactions. That's what I discussed in the last PowerPoint, presentation. So, what I mean by general acid catalyzed reaction, that it should be, catalyzed by acid as such. So, here H plus ion may not affect. Okay, in a specific acid catalyzed reaction, H plus ion is main important player. So H plus ion, if you increase the H plus ion concentration, then rate of reaction will increase. Okay, rate of reaction will increase. So please keep that thing in mind, that there is a difference between general acid catalyzed reaction and a specific acid catalyzed reaction. One is catalyzed by acid itself, and another is catalyzed by H plus ion. So for example, acetic acid you take, and then take formic acid. If you take, concentration of both of them same, and if suppose both of them catalyze some reaction, then equal concentration will give you equal, okay, equal concentration of acetic acid and formic acid. But if it is acidic, specific acid catalyzed reaction, that will not be a case, because H plus ion formed in both of the reaction will be different, because their acid dissociation constant is different. So the one in which H plus ion form in greater extent will catalyze the reaction to greater extent. Is this okay? Is it clear?
Yes.
Okay. So now let's try to understand that how we can go. If we know that, then how can we uh, write a mechanism, okay, for that. So H plus I, then K can be high, BH plus I, this is for a specific acid catalyzed, this is for your general acid catalyzed. If BH plus is high, then K will go up. BH plus low, that K remains constant. Suppose you take that case, so this reaction is only acid catalyzed reaction. So what can rate law will be written, okay? In case of general acid catalyzed, catalyzed reaction. Okay, general acid catalyzed reaction. What you will get? Something like that. Am I right? K S BH plus K dash BH plus K double dash. So suppose this kind of reaction is there. That if I increase BH plus ion, then rate of reaction increases, but after some time it becomes constant. Okay. So similarly, if this is a general acid catalyzed, then what will happen? First it will increases, and then it becomes constant. This is generally has been seen in case of uh, acid catalyzed reactions. So for that, what kind of rate law you can write? So if you see, suppose this kind of curve, then what you will write for K versus BH plus having this graph, you will write something like that. Am I right? K into S into BH plus K dash BH plus K double dash. Am I right? So this kind of things you can write, and you can see that if BH plus is low, it means rate of reaction is first order. So you can neglect this part. Then BH plus is this rate of reaction is first order with respect to BH plus. That's what you are seeing here. And then if BH plus is quite high, then K double dash goes away, and then you have K dash BH plus, and BH plus cancels out, and then you have zero order reaction with respect to your with respect to uh, BH plus. Okay. So this is your general for general acid catalyzed reaction. Again, substrate also, substrate it will be always like first order with respect to substrate. Okay, substrate certainly is going to also affect. So this is the way generally if there is a general acid catalyzed reaction, then you will this is the rate expression which you should expect, because what you have seen is K versus, if you plot K versus BH plus, this can be done, can be seen in the lab. You measure rate or rate constant with respect to BH plus I, and if it goes this, then you know that rate loss should be this. Okay. Uh, then, so for this general acid catalyze, so K versus BH plus looks like this. That's what I was talking about. Then you will write this. One thing which you need to keep in mind is generally what we do is we don't look at BH plus at a given time. What we generally plot is K versus BH plus naught, and then K versus S naught. You can do same thing. So K versus S naught. So that's what you look at. So basically, this is not the right way to write this rate law, because what you are looking at initial concentration of BH plus. So it is better to write like this: K into S naught into BH plus naught, K dash BH plus naught plus K double dash. Okay. For a specific acid catalyzed reaction, similarly, you can write rate law as K into S naught into H plus naught, K dash H plus naught plus K double dash. Am I right? So this is the way to write. Now, a problem with this is that generally we take some acid, for example, BH plus. This is okay, but for this, we generally start with BH plus. Am I right? Take some acid, for example, you can take acetic acid, you can take any other acid, and you know what is the initial concentration, and from that you need to express this whole equation in terms of BH plus naught, because that's what you know. So what can be done is that you know that how this H plus comes. We know that BH plus gives you B plus H plus. Am I right? So Ka will be written as B into H plus by BH plus. Okay. So if you write K and if you express in terms of naught, you can simply write this. Okay. And now this H plus naught can be written as K into BH plus naught by B naught. Okay. That's what is written here. So K into K, there will be one different rate constant. S naught BH naught plus naught by B naught for this H plus, and the K2 other rate constant you can take in a different way. So this is rate constant not same what you have written here. So K2 BH plus naught by B naught plus K double dash. And if you solve this, then what you will get is this reaction. So K into S naught BH plus naught, K dash BH plus naught plus K double dash B naught. So these all are, you know, uh, written in terms of initial concentration. Please keep that thing in mind. Okay. These all are written in terms of initial concentration. So if you want to write a general equation term, what you will write is something like this. Rate law is K is naught BH plus naught by K dash B plus K double dash BH plus naught plus K triple dash. So this takes into consideration everything. Okay, all these two different kind of cases. So you see here BH plus naught plus K double dash, whereas this is K dash BH plus naught plus K double dash B naught. So if we combine this, we can simply write K dash BH naught plus K double dash B naught plus K triple dash, something like that. You can always write. Okay. Now question is, from this, how we can get the mechanism of the reaction. And then from that, under which condition one reaction can be acid catalyzed and general acid catalyzed, and under what condition it can be base catalyzed, that need to be written. Okay. Problem with that is, till now what we have discussed is generally in terms of concentration at a given time. Concentration at a given time, not in terms of concentration at uh, concentration at initial, not in terms of initial concentration. So let us think about how we can get this thing. Am I right? For example, if you remember that I told that there, if suppose there are three steps here, three things, then there should be three steps. Am I right? If there are three terms in denominator, there should be at least three steps. But that was that I discussed when we have uh, three concentration terms or three terms in denominator, which is basically written in terms of your written in terms of initial concentration at a given time. What happens if I write, for example, something like this in terms of initial concentration? Okay, so let us go and derive that. If okay, so let us what we did, A plus B giving you, suppose I plus P1 and I plus C gives you P2, something like that. If this is suppose the reaction, right? What will be the rate of reaction? Can anybody tell me? Suppose this is K1, this is K minus 1, and this is K2. What will be the rate of reaction? Can someone say? I think someone is talking. Yes. क्या होना चाहिए?
So K1 AB
Yes.
upon
What?
K1 AB
AB
into क्या ये CB होगा क्या AB CB होगा ऊपर न्यूमरेटर में
C होगा. Okay.
अपॉन कांस्टेंट P1 प्लस कांस्टेंट C
Some constant P1 plus
कांस्टेंट into C
constant into C. Is this okay? Anyone? So what I will write, di by dt will be K1 AB, am I right? Minus K minus 1 A sorry I into P1 minus K minus 1 I into C. Am I right? And this should be 0. Then what will be the I? I is equal to K1 AB by K minus 1 P1 plus K, sorry, this is K2. K2 into C. And so rate of reaction is equal to K2 into C. So K1, K2 into A, B, C divided by K minus 1 P1 plus K2C. You see, that's what Mary written here. So in fact, now since you have done so much practice, you should know what should be the rate of reaction. Am I right? So certainly K1 और क्या आएगा यहाँ पे K2 because there is K2. K1 is for this. So K1 K2 होना चाहिए. P1 के साथ क्या आएगा K minus 1. That you can also say. And then C के साथ क्या आएगा K2. So in fact, if you know the mechanism and rate of reaction, it is very easy to write. So this we have, if you look at this, we have written in terms of concentration at a given time. This is not in terms of initial concentration. So suppose I want to write that. So how I will go ahead? Okay. So same thing I am going to write A plus B, A plus B, C plus P1, and then your sorry, I plus P1 and I plus C gives you product. Okay, and let's write K1, K minus 1, and then K2. So again, I will write di by dt is equal to, now I will try to express this in terms of initial concentration. What I get? K1 AB minus K minus 1 I P1. All right, and plus minus K2 into I C. Okay. So suppose this is kind of reaction. Okay. Suppose I take A into A as A in excess. Then what I will write? K1 A0 into B minus K minus 1 into I into P1 because I have taken one in excess. I into C is equal to 0. Okay. Now let's write B in terms of A0. What you will like? K1 A0. B is, what will the I? Amount of I? A plus B. Let us take this case. Maybe that will be much appropriate. So what we are going to write? BH plus S. So it is same thing. You know, BH plus S, SHH plus B. Okay. And then SH. So this is your acid and this is your substrate. This is your this SH plus B and then SH plus W. Am I right? That's what we are trying to write here. So B will be what? Can I write in terms of I? इसका मान लो कि B है initially, okay, and this is 0 0.
Is A still in excess? Like in that case, you are asking for B or?
A is in excess. So
Okay.
what I am writing A plus B giving you I plus P1. Am I right? And so this is A minus, suppose A, and this is B. This is 0 0. So this is A minus X, B minus X. So this will be X, X. Is this okay?
Yes, sir.
Okay. And this is since A is quite greater than A minus X, then you will write this. What about
A
B? B will be B naught minus
X.
I.
Okay.
Is this okay? So you simply write B naught minus I. IC is equal to 0. Now what will be the I term? K1 A naught B naught. This will be K naught A naught B naught minus. What about I? If I take I common, what I will get? K1 into A naught. Am I right? Here. And from this, is equal to 0. Okay. So what will be the I? This will be plus. All right. K1 A naught plus K minus 1 P1 plus K2 C. Is this okay? Now you compare with the first one. यहाँ पे कितना terms था नीचे? 2 terms. When I am expressing this in terms of initial concentration of A and B. Concentration at a given time for A and B. But if I same thing I am expressing in terms of initial concentration of A and B, then there is one more term. ये तो term पहले से था, ये term पहले से था. Am I right? What you have increased? K1 A naught. Am I right? What about A? We initially assumed that this A was in excess. Then this term comes K1 A naught. If I assume that B is in excess, what will happen? Here there will be term K1 B naught, not A naught. So please keep this thing in mind, because that is very important when you are trying to look rate law in terms of initial concentration of the reactant. Okay, initial concentration of the reactant. If C is suppose quite high, then you will write another C naught, K2 C naught. In fact, K2 into C naught will be a constant term. because this term is also constant. So K2 multiplied by a constant will also be a constant. But there is a 3 term. So if you express rate law in terms of initial concentration, and you see if there is 3 terms in the denominator, it means that there will be 3 minus 1 steps at least in the reaction mechanism. Please keep this thing in mind, because most of the time what we generally look at in the lab is rate law in terms of initial concentration, not in terms of concentration at given time. Okay. Then if you understand this, if you have any question, please just let me know.
So A naught and B naught together cannot be in high concentration, right? Because then I won't be
Yeah,
limiting.
you will not be able to solve that.
You won't get a
Okay.
steady state for I, right? In that case.
Not about a steady state, but you will not be able to write like this. Then there will be, a naught minus I. There will be this term also. Okay. So please keep that thing in mind, that it has to be one. If we, that's how we do, measure rate law in the lab also. We keep one of them in excess, and then we look at how rate of reaction changes. For example, catalyst and substrate. Suppose there is a catalyst and substrate. You take one in excess and then look with respect to other. Okay. So if you get 3 terms in denominator, then you should have you should have at least 2 steps in the mechanism. So please keep that thing in mind. And you know that what will that term be. It is again easy, because one of them you have already taken in excess concentration. So you can just simply keep that thing out. So what is left is these 2 terms. So this must be, since this is a product, it must be formed in one step prior to rate determining step. And this will be involved in the rate determining step. Okay. So if you have this thing in mind, then you can go ahead and tell me what can be the, so this is, you remember that. This is the term K dash B plus K double dash BH plus naught plus K triple dash. Okay. Now what can be the mechanism? So B the product. So there should be at least 2 steps. Am I right? There should be 2 steps.
Yes, sir.
Okay. BH plus is catalyst and S is substrate. What need to be formed? So you wrote 2 steps. First is equilibrium step. Second is the rate determining step. Okay. Where should B would be formed? At this step. Okay. And what should be involved in the next step? Either it should directly go to S plus SH plus 2 product, or you see this is a constant term. This may involve some reactant whose concentration doesn't change. वो क्या हो सकता है? Water molecule. So BH plus plus S, just by looking at this, I can write a general mechanism. BH plus plus S giving you SH plus plus B, SH plus plus W. BH plus is reactant, you remember that. And this is not. So it means that this you will get when you take acid in excess. All right. Then only you will get it. And that you can derive. So yeah, so this, so what I told, that rate of reaction is given like this: K minus 1 B plus again B naught, you can say K1 BH plus naught plus K2. Now think about this is the rate law. We have already discussed mechanism. What can be the mechanism? But when it can be general acid catalyzed, when it can be a specific acid catalyzed. Now, remember K minus B, if I neglect this, I get this term, am I right? And then it is simply general acid catalyzed. General acid catalyzed reaction. Okay. Now you see when it can be acid catalyzed. So you have to divide by B here. Okay. So what you will get? K1, K2. If I take this K2 is quite less than K minus 1B. So what will happen? This K2 can be neglected and you get this term. Am I right? If you get this term and now you can divide by B, and if you divide by B, then you will get BH plus by B naught, BH plus by B naught, and this is equal to Ka into H plus ion. Ka into H plus ion. So you have a specific acid catalyzed reaction. So what does that mean? General acid catalyzed when K minus 1B is quite less than K2. What does that mean? That this reverse reaction is very slow. Then you get general acid catalyzed reaction. When it will be a specific acid catalyzed, when the second step is slow. Second step is slow, then you will get this specific acid catalyzed reaction. So please keep these things in mind. You know, same thing, mechanism. Now what I am trying to look at, that if rate law is given in terms of initial concentration of reactant, then what, how to write a reaction mechanism. If there are 3 terms in denominator, then 3 minus 1, 2 terms, 2 step, there should be at least 2 steps in the mechanism. Then you neglect the reactant term, which is acid here, right? Then you will remove K1 BH plus naught, and what you are left with 2 terms. In one term, there is a product involved, and so it must have formed in the equilibrium state. Or you can see I react with B, and in the one step I is either not reacting with any reactant, or I is reacting with a reactant which is in excess. Certainly it is not A and B, but it may be some C molecule, which in this case is water molecule. In this case is water molecule. So this is how mechanisms are derived. So, you know, now you know when a reaction will be catalyzed by acid, when reaction will be catalyzed by a specific acid. What I mean by a specific acid, that it will depend on H plus ion concentration. So if you take concentration of acid same, weak acid same, the effect will be different, because same acid, different acid of same concentration, particularly weak acid, will not give you H plus with the same concentration. So again, it will depend on Ka value, acid dissociation constant. So that is what I mean by a specific acid catalyzed. When it is general acid catalyzed, then any 2 acid with equal concentration will have equal effect. That is the difference between general acid catalyzed and a specific acid catalyzed reaction. Is this okay? Any questions here?
Sir, if it like, can we see it this way that if it's general acid catalyzed, then the BH plus concentration has to be considerable. Like we should be able to notice it, because if it's staying constant, then it won't change according to general acid catalyzed. That's why we are having that BH plus. Like in that terms, how can we look at it? Uh,
You see, even a BH plus ion, when we say it is in excess, this is about the rate law. In this also BH plus can affect. Now question is how
yes.
much in excess it is.
Yes.
Right? You see here that initially if I increase the concentration of BH plus ion, okay, then what will happen? It will be first order.
Yes, sir.
And then if it is in excess, then what will happen? This BH plus ion
Zero.
cancels out.
Yes.
Okay. So it is like this. This is the same thing, but this is the way you will get it. K versus BH plus ion concentration.
Yes.
If you want to see the effect of substrate, then you should plot K versus substrate. In that case, what happens that substrate BH plus ion, then you can take in S plus, you can take in excess, then there will be a term S naught in the denominator. Right? S naught, then there will be not BH plus concentration in the denominator. In fact, in if you go and try this thing, uh, so let me S plus BH plus giving you SH plus B. Okay, and then this SH plus, which is your intermediate, plus water, suppose gives you product. Now derive that by taking S in excess. What you will get? What you will get? I can simply tell you. What you will get here? K1 into S naught plus क्या होगा बताओ? K minus 1 क्या होगा? B. You see K minus 1 into B, and then K2 into W. But W is constant. So what you will get? This is simply constant. ऊपर क्या होगा? K1, K2 क्या होगा बताओ? S naught
It's not
into BH plus
H
naught.
plus.
Water होगा, again water will be a constant. If you want to take, you can take also water. So this is, so now you know that you don't have even to write a steady state approximation. You can simply write it. But this will be the term. इसको कांस्टेंट ले लो, ये सारे कांस्टेंट ले लो, then what you expect? If S naught is negligible, then what will happen? Compare to this. Again, I am comparing with this. Okay. Then what will happen?
First
This
order
is
with respect.
first order. Otherwise, it is zero order.
Zero order.
Okay. So this is the way to derive your, derive the mechanism. Hello, just call me after 5 minutes. Okay. But please note it down that the things which you have taken in excess will be, will also come in denominator. Please just neglect that. What is left is these two terms. This is your product, and so you can simply write that this must have formed in the one step prior to this. So this is B, and in this either no reactant is involved or solvent molecule is involved to give you product. Is this okay? So
So
yes.
So when we are saying S naught is very small, then it is first order reaction. But then S naught would be fixed for one experiment. So what is that first order thing?
What, again, can you repeat your question?
If S naught is very small, then
No,
it is
I'm
fixed
not saying very small. Okay, so
comparatively.
yeah, so apparently, what I mean simply is that because remember that this is again uh, in comparison to BH plus, this is large, okay, but as such it is uh, you know means in the large also you have to start with a smaller quantity, am I right? A smaller quantity, then you are increasing this, okay. So that's what I mean by that. Is
So
this okay?
when we say about it, experiment that water in this case, how are we determining that? Like it is only by the knowing that what kind of reactants will form.
What kind of product is formed? From that you can know
Okay.
whether water is involved or not. Okay, water is
Yes, sir.
involved or not, you can also know just by uh, knowing, and also you know that what will be the transition state composition, right? That I have already discussed how to get transition state composition. So you remove this thing, remember this thing, remove this thing, then you will get in terms of simply concentration at given time, and then slow step you uh, you know um, uh, slow step is this one, so neglect this and then you calculate from this what will be the composition, right? So this you remove because this is a slow step, then only you can determine what will be the rate of what will be the composition of this, and then you solve what can be the composition, okay. Once you do that, then you can know whether water is involved or not. I've already shown one of that example, am I right? यहाँ पे water involved था last step में. We have looked
Yes,
at
sir.
one of such example, am I right? So just it will also go like that. So carbocation form हुआ था, उसमें water involved था, then you have a alcohol, am I right? So please keep that example in mind, then you will know, because composition should also match with the composition of reactant in rate determining step. Is this okay?
Yes, sir.
चलो तो आज stop, we will stop here.
So
Yeah,
on slide 14, could you show that?
yes, tell me.
So in the last step, we are dividing by B or B naught?
B naught, yeah, just okay. Take B naught, because all we are taking as a B naught.
So K minus 1 is multiplied with B naught here. Okay. Okay.
ये भी B naught होगा, am I right? ठीक है, ये भी B naught कर सकते हो, सारा B is equal to B,
Okay.
okay? जो एक्सेस में लिया है उसको either you write B or B naught, it doesn't matter, okay? Is this okay?
Okay. Yes, sir.
So I will stop here. If you have any problem, please write me an email. Then we
Sir,
can all discuss.
sir,
Yeah, yeah.
sir, can you please upload the